Hi students, in this video we'll be discussing about short answer questions of 7th chapter classification of elements, the periodic table. These are the important questions which were given in the Abhyas Deepika. Okay, the short answer questions, 4 marks questions, total of 10 questions were 5 questions were given, a total of 5 questions were given. So in the first question is which one, the questions will be displayed on the screen. Please see the questions and I'll be solving the answer. The first question is which one between Cl and Cl minus would have more size Y? Which one among or between Cl and Cl minus ion have more size? Why? That is the question. Okay, so we need to discuss which one among Cl and Cl minus have more size Y. So Cl means chlorine atom. Chlorine, atomic number is 17. Its configuration is 1s2, 2s2, 2p6, 3s2, 3p5. Now, if I write this shell level configuration, it is 2, 8, 7. And I will draw the shells. Here nucleus, 17 atomic number means it contains 17 protons and 17 electrons are there. So nucleus has got 17 protons. First shell has got 2 electrons. Second shell has got 8 electrons. Last shell has got 7 electrons. Remember that. Okay, now I will go the Cl minus, chloride ion. Cl minus is nothing but this is a chloride anion. Minus charge means anion. So chloride minus anion. So if you observe, chlorine does not have any charge on this because it is a neutral atom. And Cl minus is having a minus charge. Cl is having minus charge here. Chloride ion is having minus charge, which is called anion. So by this we can understand that it may have 1 electron excess. Now chloride ion, it is having only 17 protons, but electrons have become 17 plus 1 is added. Because chlorine atom, if it gains electrons, it will be converted into chloride ion anion. So that is Cl minus anion means it contains 17 protons and 18 electrons are there. Remember that. Okay. Now this is chlorine atom. Now I will draw for chloride ion. Okay. So Cl minus ion. For that I am going to show you the nucleus of even chloride anion is also having a 17 protons. And first shell is having 2 electrons, second shell is having 8 electrons, and even last shell is also having 8 electrons, because if I write chloride ion configuration, and it will be like this 2, 8, 8. So compared to this chlorine atom, 1 electron is excess in chloride ion. Okay, so if you observe the attractive force between the 17 protons present in the nucleus of chlorine atom and 7 electrons present in the last shell of the chlorine atom. A total of 17 electrons are there, but last shell is having only 7 electrons and nucleus is having a 17 protons are there. So there will be attractive force between the nucleus and the electrons present around the nucleus of this chlorine atom. Okay, that is more attractive force. There exists a more attractive force between 17 protons and 17 electrons present outside the nucleus, especially 7 electrons present in the outside the nucleus, that is third shell. Now if I call the chloride ion is having 8 electrons in the last shell. So the 17 protons present in the chloride ion, nucleus of the chloride ion, cannot exert much attractive force or much pull towards the nucleus, because we are having 2 electrons, 8 K shell, L shell, M shell. Here we are having 8 electrons are there. So the electron repulsion is 8 electrons more repulsion compared with 8 and 7 electrons between these two if I compare. So there is a chance of more repulsive forces between the electrons present in last shell and even the L shell. This is valence shell, penultimate shell, anti-penultimate shell. And the attractive force for nucleus cannot exert much pull. Okay, it can't attract all the electrons towards it easily because more electrons are there. and that too electron repulsion is there. Electron number is more. Electron cloud is more. So because of that, the atomic radius or the size of the chloride ion is more than that of the chlorine atom. Reason is more electron cloud, more repulsion between these two, and not only that, even nucleus cannot exert much pull towards it. Okay, because the excess number of electrons are there. Nuclear charge is same in both the cases, but the electron number is 7 here last shell, here is 8. And electron repulsion is more because of more electron cloud. Okay, here electron repulsion is, compared to this one, is less and more attractive force or pull towards the nucleus. So here less attractive pull, attraction force, and here less attraction force, here is more attraction force. So electron cloud is more here, electron cloud is less. Hence, the chloride ion is having a more size than that of the chlorine atom. That is the thing. Very, very important explanation. Very important question. This kind of questions may be asked. Now, the second question is, the ionization energy required to remove an electron from Mg plus C is higher than the ionization energy required to remove an electron from Mg. Why? The ionization energy required to remove an electron from Mg plus. Now, the second question is, the ionization energy required to remove an electron from Mg plus is more than Mg. Why he is asking? The question is like this. The question will be displayed on the screen. The ionization energy required to remove an electron from Mg plus is more than Mg. What is the reason for this? Reason is, if I talk about magnesium, Mg plus and Mg, I will talk about both. Magnesium atomic number is 12. It contains 12 electrons and 12 protons are there. Nucleus of magnesium is having 12 positive charges. First shell is having 2 electrons. Second shell is having 8 electrons. And last shell is having 2 electrons. Now, if in case of Mg plus, how this magnesium is going to convert into Mg plus if it loses electrons? Because magnesium is a metal. So, metals has got an ability to lose the electrons more easily, whereas non-metals can able to gain the electrons easily to become octet. So, here Mg plus, if magnesium loses 1 electron, it gets converted into Mg plus ion. Okay, that is plus 1 charge, that is cation. So, Mg plus is having 12 protons in the nucleus. Protons won't be affected, and nucleus first shell is having 2 electrons, second shell is having 8 electrons, last shell is having only 1 electron. Remember that. So, ionization energy required to remove an electron from Mg plus is more than Mg. Now, if I want to remove the electron from this Mg atom, magnesium atom, we require less amount of ionization energy. Reason is, nucleus having 12 positives are there, and outside the nucleus in the last shell we are having 2 electrons are there. Outside the nucleus we are having total of 12 electrons. 2 electrons in the first shell, second shell 8 electrons, last shell 2 electrons. It is a neutral atom. So the amount of energy required to remove an electron from the neutral atom is less compared with the cation here, because here we are having only 1 electron outermost shell. A total of only 11 electrons are in Mg plus. Only 11 electrons and 12 protons are there. Compared with the number of electrons present outside the nucleus, there is a more nuclear charge, more charge in the nucleus because 12 protons are there. Outside the nucleus, we are having only 11 electrons are there. That in the last shell only 1 electron is there. So, there is a chance of more attraction force towards the nucleus. Nucleus will try to pull the electrons towards it more easily because nuclear charge is more here because number of protons are more. As the number of protons are more, nuclear charge is more. There is chance of attractive force more towards the nucleus. So it is very difficult to remove the electron from this particular Mg plus because of more attractive force. As Mg plus cation, this one. More number of protons, more attractive force towards the nucleus. And here, nucleus having 12 protons, outside the nucleus we are having 12 electrons. So charges are balanced. In the nucleus plus 12, outside the nucleus we are having 12 negatives are there. So same amount of force will be exerted by the nucleus on these and by these electrons on the nucleus. Whereas here if you compare, the attractive force exerted by the nucleus is more compared with the attractive force exerted by the electrons on the nucleus. So the pull towards the nucleus is more attractive force. So it is very difficult to remove the electron from this Mg plus compared with the Mg. Hence, Mg plus is having more ionization energy. Mg plus is having IE is more than Mg. Here is Mg plus and here is Mg. Remember that, very, very important application question. Okay. Third question is, in the periodic table, elements arranged in a group possess similar properties, but elements in a period do not show similar properties. Similarities in their properties, why? I will read out the question. Just see the question on the screen. In the periodic table, elements arranged in the group possess similar properties, and whereas the elements present in the period, do not show similarities in properties or will show different properties. Why? So, for example, the elements present in the group. Now, the third question we are discussing. Okay, the elements present in the group, for example, first year group elements. We are having is hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. Okay, hydrogen atomic number 1, lithium is 3, sodium is 11, this is 19, this is 37, this is 55, and this is 87. So, whereas elements present in the period will show dissimilarities in properties, means different properties. Example, I will talk about second period elements. Sir, why not first period? You can go with the first period also, but it's better to take second period elements. So, the lithium we are having is beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon is there. These are first period elements. These are first period elements. These are second period elements. This is first year group. I will be talking about second period elements. Second period elements. And if you wish me to explain, I will go with the second group. Otherwise, go with this is second year group. We are having beryllium, magnesium, calcium, strontium, barium, and radium. So, beryllium atomic number is 4, magnesium is 12, and calcium is 20. This is 38, this is 56, this is 88. Okay, so we are having is, I will explain. It's better to understand. Okay, with the second year group and second period elements. We are having in the second period. I will start with this particular one. I'm not taking the first year group. So why? I will read out the question again. In the periodic table, elements arranged in the group possess similar properties. The elements present in a particular group will have similarities in properties, whereas the elements present in the period will show dissimilarities in properties, means different properties. Why? The main reason is that I wrote here is second year group elements, which are called as alkaline metals, alkaline earth metals, beryllium, magnesium, calcium, strontium, barium, and radium. Even these are the atomic numbers. Okay. Now I'm talking about all first year group elements are having the main reason to show similarities in properties. Okay, in case of the elements which comes under same group is because all the elements are having a valency same. Because of same valency. All the second year group elements, okay, are having a valency 2 because they all are having last shell electrons, only 2 electrons are there. Example, beryllium. Atomic number is 4, configuration 1s2, 2s2. First shell is having 2 electrons, second shell, last shell is having only 2 electrons. Even in case of magnesium also, last shell is having only 2 electrons. Calcium also having last shell 2 electrons. Strontium also last shell 2 electrons. Barium is also having last shell 2 electrons, whereas radium is radioactive in nature. Okay, so most of the cases, all the elements which are present in a particular group, which comes under same group, will show similarities in properties. The reason is because they are having the same common valency. That is the main reason. Okay, next, in case of the elements which comes under a particular period will show dissimilarities in properties, means different elements are having different valencies because they belong to different groups. For example, beryllium, which comes under second year group, is having a beryllium. Here in this case, beryllium, in case of period I am talking about, these are second period elements. So in case of beryllium, atomic number is 4, its valency is 2. And boron, atomic number is 5, its valency is 3. Nitrogen, atomic number is 7, its valency is okay, not nitrogen, go with the beryllium, valency is 2, boron is valency 3. Carbon is, atomic number is 6, valency is 4. Again, nitrogen, valency is 3, atomic number is 7. And oxygen is atomic number 8. And valency is atomic number 7. This is valency 3. Oxygen atomic number is valency is 2. Fluorine atomic number and valency is 1. Neon atomic number 10, valency is 0 because it is an inert gas. So the elements which comes under same period will show dissimilarities in properties. The reason is because they all are having different valencies and which belongs to different groups also even. Boron comes under, beryllium comes under second group, boron comes under third group, third A group, carbon comes under fourth A group, nitrogen comes under fifth A group, oxygen comes under sixth A group, fluorine comes under seventh A group, and neon comes under eighth A group or zero group elements are also called noble gases. Is it clear? Next one, next question will be solving. An element, next question you please see on the screen. An element X belongs to the third period and a group 2. An element was given. An element, next question is, that is a fourth question. An element X belongs to, he has given, an element X belongs to third period. Is telling is third period and second group. And second group. Okay, of the periodic table. State the number of valence electrons. Remember this. Please remember this. The group number, if he is giving, how much the group number is 2. Then it belongs to second group means the valency of that X element valency electrons is 2. First point. Next one is, okay, its valence electrons is 2 and the valency of the element is how much means 2. Valency is 2. He has mentioned the group number tells about the number of valence electrons in one way, and valency of the element also it can able to describe. Sometimes that is valency is 2. And next one is it belongs to, okay, which period? It belongs to which period? Number of valence electrons is 2. Sir, third period na? Third period element and second group. Second belongs to third period, second group. Second group means valency is 2 because valence electrons is 2. And it belongs to third period. Okay. So he has clearly mentioned the first question answer is, I will read out the question. An element X belongs to the third period and second group of the periodic table. State the number of valence electrons. Group number tells about number of valence electrons one way. Okay. Metallic property. Now you have to remember he is talking about third period second group. But he did not mention clearly second A group or B group. We can understand by seeing this. It is 99% belongs to, okay, that is second A group. Now if I write second A group elements we are having is beryllium, magnesium, calcium, strontium, barium and radium. Understood? So second group, these second A group elements, beryllium, magnesium, calcium, strontium, barium and radium. And here this beryllium comes under second period. And he is telling about third period na? Then third period, second A group element is which element? Magnesium. Remember that. So the element is magnesium. Element name is Mg magnesium. And metallic property, magnesium is next question on the screen is, he asked B question under fourth question. A is number of valence electrons is 2 and the valency of the element is 2. And metallic property, magnesium is a strong metal. Strong metal. Very clearly understandable. This particular question we can solve more easily. Now the last question which we are going to discuss is the electronic configuration of the element X, Y and Z are given below. Electronic configuration of the element X, Y and Z given below. Please see the question on the screen. And X electronic configuration is 2 was given. This was given is shell level configuration. Second element electronic configuration is 2, it was given as 6. Okay. And last element is 2, 8, how much 2 was given. Remember that. Now here, so 2, 2, second one element is 2, 6, third element was given is 2, 8, 2. Is asking to which group. Now the questions are, which element belongs to second period? Okay, the first question is, which element belongs to second period? And next question is, which element belongs to second group? He is asking to find out second period element and second group elements. Okay. Now this is electron shell level configuration was given. So this is 2 electrons are there here. 2 electrons means 1s2. First shell is having 2 electrons means 1s2. The element we can guess is helium. And here is total number of electrons, how many? 2, 6. 2, 6 means total number of 8 electrons are there. That is total 8 electrons are there. Now I will write orbital level configuration. First shell is having 1s2. Second shell total how many electrons? 6 are there. Then I can write 2s2, 2p4. And next one I can write this one as total how many electrons are there? 2 plus 2, 8, 2. 2 plus 8, 10. 10 plus 2, 12. That is 12 electrons are there. Which element it is? We'll guess later. Now configuration is 1s2, 2s2, 2p6, 3s2. Remember? So if you observe, if I compare these 1s2 configuration with NLX method, now I will compare 1s2 with NLX. So here n is equal to how much? 1. So the principal quantum number tells about to which period does it belongs to. Now if n is equal to 1 means first period. N is equal to 2 means, in this case n is equal to how much? 1. So this element belongs to first period. Helium belongs to, I will write very clearly. Helium belongs to first period. Helium belongs to first period. And now second element. Now 8 electrons are there. Total number of electrons are 8. So electron number tells about what is the atomic number of the element. Now 2 plus 6, 8 electrons are there. I will guess this element is oxygen. Okay. And next one is this element is 12 electrons. 2 plus 8 plus 2, 12 electrons. The element is magnesium. Now here n value is how much? In this case 2, 2. Both are having n value 2. So by seeing the n value 2 means it belongs to which period? That is second period. Now the oxygen element belongs to which period? Second period. And in case of this one, Z also we have is, okay, Z is 282. Last shell electrons how many? 2, 8, 2. Last shell how many are there? 3 electrons are there. The two electrons are there. These 2 electrons comes under which period? 3 means, n value 3 means third period. So there is element magnesium belongs to third period. And the first question he asked is, which element belongs to second period? Now by observing this, the element oxygen belongs to which period? Second period. That is, here is Y belongs to, the answer is Y for this case. The element Y belongs to second period. And second group. Sir, how to find out the group number, sir? By seeing the number of valence electrons. No, in this case, valence electrons are how many? 2, 2 and 4. 2 plus 4 how many? That is 6 electrons. So then oxygen, this element Y belongs to 60A group. And next Z element. Last shell electrons, how many are there? Last shell, third shell. How many electrons are there? 2. So this number of electron number present in the last shell tells about group number. So that is magnesium element. Element magnesium belongs to second A group. That is the thing. So with this, we completed discussion about this 4 marks questions which were given Abhyasa Deepika. If you like my explanation, please like, share, comment and subscribe. Thank you.